All right, Chapter 5, Section 1, Systems of Linear Equations in Two Variables. All right, so a system of equations is an equation, or has two equations that are side by side, okay? And the answer to a system is an ordered pair that is a solution to both parts, okay? Normally, a normal equation has lots of answers, okay? If you remember, we can graph these. These would be lines. All right, but a solution to a system is an ordered pair that works for both. Okay, so the first thing we gotta do is determine whether an ordered pair is a solution. And if you can do this, this is your checking mechanism when we actually solve these out. So if you want to determine whether 4, -1 is a solution to the system, okay, is you want to plug the 4, -1 into both equations. And I'll call this one equation 1 and then equation 2. All right, so you want to plug 4, -1 into equation 1. All right, so in equation 1, the 4, remember, is your x value, so I'd have 4 plus 2 times the y value of -1. And we're saying, is that actually equal to 2? Well, multiply 2 times -1 is -2. And is 4 minus 2 equal to 2? It is, so that does work out for that one. All right, but I'm not done yet. I'm not sure if it's a solution to the system because I got to make sure that it works in equation 2. If I plug it into equation 2, all right, I get 4 for the x minus 2 times the -1 for the y. Is that equal to 6? All right, well, the minus 2 times the -1 gives me plus 2. And since 4 plus 2 is equal to 6, that works as well. So yes, that is a solution. All right, we can try B, see if -4/3 is also a solution. All right, well, let's try it out for equation 1. All right, is -4 for the x plus 2 times 3, is that equal to 2? Well, -4, and then 2 times 3 is 6. And -4 plus 6 is, in fact, equal to 2, because 6 minus 4 is 2, so it works for equation 1. But remember, for it to be a solution to the system, it has to work in both. So let's see with the second one. -4 minus 2 times 3, is that 6? Well, -4 minus 6, well, that's not 6, so that's going to be a no. It's not a solution. Okay, and that's your checking mechanism. All right, now, we've got a couple of different ways we're going to do these. Substitution. Okay, and substitution is useful if you can either one of the equations already solved for a variable or it's easy to solve one of them for a variable. Okay, so you're going to solve one of the equations for a variable. You substitute that expression into the other equation. That'll give you an equation with one variable. You'll get that answer and then back substitute it in to one of the originals to find your answer and then check. All right, so to solve this one by substitution, okay, I'm going to go ahead and label my equations so I can talk about them. Equation 1 and equation 2. The first step is to solve one of these equations for a single variable. All right, and equation 2 is going to be the one I'm going to want to work with because I don't have a coefficient of the x. So I can take equation 2, x minus 2y is equal to -3, and I can solve this for x. I can get x by itself. So I can add the 2y over. That gives me x is equal to 2y minus 3. That's your step 1. Solve one of the equations for a single variable. Now, since I used equation 2, I'm now going to flip over to equation 1. All right, now I'm going to rewrite equation 1, but instead of the x, so 5 times x minus 4y is equal to 9, I'm going to substitute in what I knew was x in equation 2. According to equation 2, x is 2y minus 3, so I'm going to stick that in there where x should go in equation 1. So 5 times 2y minus 3 minus 4y is equal to 9. Now that equation only has one variable, and it's just solving that equation. Let's distribute. That becomes 5 times 2y is 10y. 5 times minus 3 is a minus 15. Minus the 4y is equal to 9. Combine like terms, so this becomes 6y minus 15 is equal to 9. Add the 15 over, so 6y is equal to 24. Divide the 6 over, so y is equal to 4. That's half your answer. The solution to a system is an ordered pair. So once I get the 1 answer, I'm going to back substitute it into either one of the equations. Okay, so I like equation 2. So if I back substitute, and I'm going to use equation 2, you don't have to. You can use equation 1. I'm going to say x minus 2 times 4, which is what I think the answer is, and that's negative 3. So now I can solve for x, and I end up getting x is equal to 5. So if I've done it right, my answer here is 5, 4, that ordered pair 5, 4. All right, and then you can check it, plug it back in. 5 times 5 is 25 in equation 1. Minus 4 times 4 is 16. 25 minus 16 is, in fact, equal to 9. Let me plug it in the last one. Equation 2, 5 minus 2 times 4 is 8. 5 minus 8 is negative 3. So check, check, it works on both. All right. That is substitution. All right. That is useful if one of the variables does not have a coefficient. Okay. You can do that without too much problem. All right. Elimination or addition, as this book talks about. Okay. Is you want to rewrite both equations where they have the x, the y, and the number. Okay. If necessary, multiply either equation or both equations by non-zero numbers so that sum of the x coefficients or the sum of the y coefficients is 0. We're trying to eliminate one of the variables. We'll do that. We'll solve the equation in one variable and then again back substitute and check. All right, so this is how it works. All right, I've got equation 1 and equation 2. It's already in a nice format where it's x, y, and number. All right, on both of those. All right, now what I want to do is I want to get one of my variables to go away. Okay, when I sum them together. So 3x plus 9x, that's 12x. That's not going away. 2y minus 8y, that's not going to go, that's going to give me negative 6y, that's not going away. So I want to multiply either one or both equations by a number in order so that those go away. Either one. Okay, and I'm going to choose my y values. I want these y coefficients to be the same number except opposite signs. So what can I multiply 2 by in order to get a positive 8? All right, it's going to turn out that's going to be a positive 4. So if I multiply the entire first equation by 4, let's see what happens. So I'm going to write it over here. So equation 1 is now going to be 4 times 3x, which is 12x. 4 times 2y is 8y. And 4 times 48, oh, that's a big number. Carry the 3, 192. Make sure I did that right before I go any further. 4 times 8 is 32. Yeah. And then equation 2, I've got 9x minus 8y is equal to negative 24. I did not have to change that one on this particular problem. Now, the reason why I do that is because I'm going to add straight down. 12x plus 9x, that gives me 21x. 8y minus 8y, those go away. And then 192 minus 24 is going to give me 168. Make sure I'm doing that subtraction correct. Yeah. All right, and then I divide out. So I divide by 21. All right, and will 21 go in there? All right, it does, actually goes in there 8 times. 168 divided by 21 is in fact 8. All right, so I've solved for one variable, and so now I'm going to back substitute. Okay, so see how that worked out. I multiplied one of the equations, or it could be possibly both, so that one of the variables' coefficients match up except opposite sides. That left me with an easy equation to work out. Now I'm going to back substitute. So I back sub. Let's see. I don't like the negatives in equation 2, so let me go back and use equation 1. 3 times 8, because that's what I think x is, plus 2 times y is equal to 48. That gives me 24 plus 2y is equal to 48. Subtract 24. That gives me 2y is equal to 24, because 48 minus 24 is 24. Divide by 2, and so y is equal to, hopefully, 12. Okay, so my answer is, I think, 8, 12, that ordered pair. All right, I go back and I check it. So 3 times the 8, that's 24. 2 times the 12, that's 24. That does give me 48. I've checked. Boom. All right, 9 times 8 is 72. 8 times 12. 8 times 2 is 16. Carry the 1, that's 96. And 72 minus 96, stick that in my calculator, that does give me negative 24. So I do know my answer is correct. That is addition method. All right, let's do one where you got to do a little bit more work with it. So I want to get everything to one side. All right, so equation 1. All right, if I get the y over, I'd have to subtract it. So 2x minus 7y is equal to a negative 17. That's equation 1. All right, equation 2. I can bring the x over. Since it's a minus 3x, it will become a plus. So 3x plus 5y is equal to positive 17. Now, again, the x's don't match up here, neither do the y's. So I want to get rid of, I want one of them to match up. So look and see which one do I want to do. All right, you could do either one. It does not matter. Your work might be more difficult one way or another. But let's see. I can't multiply 2 by anything to get 3. Can't multiply 5 by anything to get 7. But I want to go with the smaller numbers, really. So if I could get 2 and 3 both to be 6. So I can multiply the top by 3. I'll multiply that by 3. Then equation 1 now becomes 6x minus 21y is equal to 3 times 7. That's going to give me a negative 51. And then I'm going to multiply the bottom equation, equation 2, by negative 2. All right, the reason why I did negative 2 is because negative 2 times 3x will give me a negative 6x, and I want those to go away. And they do, 6 minus 6. Negative 2 times 5 becomes negative 10. Negative 2 times 17 becomes a negative 34. All right, now I'm going to do my elimination or my addition. 6x minus 6x, that goes away. Negative 21 minus 10 is going to be negative 31y. And negative 51 minus 34 is going to give me a negative 85. I divide the negative 31 over. Since they're both negative, make sure I did this one right. Yeah. Y ends up being a positive 85 over 31. All right, which unfortunately does not simplify. All right, so now I've got a back sub. Okay, sometimes your answers could possibly be horrible fractions. All right, if I back substitute, all right, I like equation 1 because that y is over here on the right. I don't have to move stuff over and over. So I have 2x is equal to somehow 7 times 85 over 31 minus 17. All right, that gives me 2x is equal to, I'll multiply the 7 through, I'm just multiplying it on top because that's 7 over 1. So 7 times 5 is 35, carry the 3. 7 times 8 is 56, plus the 3 is 9, so 595 over 31. All right, 17. I can turn that to have a 31 on bottom by multiplying by 31 on top and bottom. Try not to break my calculator out for it until the very end. So 217, 0, 1, 3. So that becomes 527 over 31. Just double checking here, guys. 31, 217. Yeah. All right, that becomes 2x is equal to, when I subtract, 95 minus 27. It's going to give me 62. No way. Not 68. Yeah. 68 over 31. And then if I divide the 2 over, or in other words, I can multiply by 1/2. I would definitely use my calculator for this one, guys. All right, this ends up being x is equal to 34 over 31. All right, so my answer here, if I've done it correctly, which if I remember from the past, I think I might have, 34 over 31, 85 over 31. All right, what you would do to check it is you would go back and plug it back using your calculator. And on the left-hand side of equation 1, you would say 2 times your x value, which you think is 34 over 31. So 2 parentheses, 34 divided by 31, that gives me about 2.194. If I plug the y in on the other side, 7 times parentheses 85 divided by 31, close parentheses, minus 17. That gives me the exact same answer. Now try the second part. 5 times the y, which is 85 divided by 31. That gave me 13.7097. I'll do 17 minus 3 times parentheses 34 divided by 31. Again, I'm plugging this into the second equation. I do get the same thing. So unfortunately, or fortunately, that is the correct answer. Unfortunately, the answer looks horrible. It's possible. Okay? All right. Now, to finish this out, solutions to system equations are going to happen one of 3 ways. Okay? Most of the time, you're going to have exactly one ordered pair solution. Okay? That's the ones we've worked so far. Okay? Graphically, what that means, you can see on the next slide, is that those 2 lines intersect at one point, and that one point is the solution. Okay? Normally, that's what happens. You could have no solution. Okay? What that means is when we graph those 2 lines are parallel, as you see in the second one. Since the lines are parallel, there's no answer where both of them work. Those don't cross, so there's no ordered pair where they both work, so there's no solution. And finally, infinitely many solutions. That means even though the equations don't look exactly the same, one of them is some scalar form of the other, and so they're actually the same line, and so we have infinitely many solutions, okay, because every single point on that line is a solution to both. All right, and so let's see how that works out. Okay, this one's set up to do the addition method. Okay, so look and see, all right, what variable can I get to be the same except opposite signs? All right, I like the x, okay, because the smaller numbers. All right, so what do 4 and 6 both go into? 12. So if I multiply the top one by 3, that becomes 12x. 3 times 6 is 18y. And 3 times 12 is 36. All right, I want the bottom one, x, to be a negative 12. So if I multiply that by a negative 2, negative 2 times 6 gives me the negative 12x. Negative 2 times the negative 9 gives me a negative 18y. And negative 2 times the 12 gives me a negative 24. All right, now you might notice something. The x's are the same but opposite signs, so they're going to cancel out. The y's are also the same except opposite signs, so those are going to cancel out. So the left is equal to 0, and the right, 36 minus 24, is equal to 12. All right, so since 0 is not equal to 12, that statement's false, and that means I have no solution. All right, so you might not be able to tell just right off the bat, but once you start working, if you end up getting 0 is equal to a number that's not 0, you're going to have no solution. Okay, and it'll either be written as no solution, or you'll see that 0 with a line slashed through it. All right. Now, system with infinitely many solutions could look exactly the same. All right, let's see how this one works. Now, this one is actually set up to do substitution. So I'm going to go and do substitution. Since equation 1 is already solved for y, I can rewrite equation 2, 15x minus 5 times, but instead of y, I'll have 3x minus 2, because that's what y was in the equation 1, is equal to 10. All right, when I distribute, this becomes 15x minus 15x. Negative 5 times the negative 2 will become plus 10. All right, and the x's end up canceling out. I'm left with 10 is equal to 10. All right, if the variables go away and I have a true statement, All right, then I know I have infinitely many solutions. Okay, you could have something similar with the addition method where you end up having 0 is equal to 0. But if you have a true statement, you have infinitely many solutions. All right, and the way that answer is going to work, look, is it probably is not going to say infinitely many. All right, but that's what it means. It's going to look like this. It's going to be the brace, that squirrely bracket. You're going to have x, comma y. You're going to have a vertical line, and then you're going to have one of these equations written after the vertical line. Y is equal to 3x minus 2. And that says this is all ordered pairs such that they work in one of these equations, because these equations end up being the same. All right, so that's how you work those. Try your My Math Lab. Good luck. Email me if you got questions.